Nargesa presents a new tutorial for the PP200 horizontal press brake and the all-new fully automated gauge, both entirely manufactured and assembled at our facilities. The new PP200 comes standard with a multi-V bend mold with 4 openings, 50, 35, 22, and 16 millimeters for different sheet metal thicknesses from 1 to 8 millimeters, and an 80-degree punch with an outside diameter of 70 millimeters to bend a piece completely closed with a minimum inner wing of 75 millimeters. Also included is a highly versatile manual gauge to perform all types of operations. As an additional option, a CNC gauge of up to 1,210 millimeters can be added to facilitate mass manufacturing. We're going to do different practical examples with these standard accessories. First, we're going to bend some sheet metal into a figure 8. To do so, the 8 sides have been marked and the 360 degrees have been divided by the 8 bends. The angle of each bend is 135 degrees. Creating bended pieces which are completely closed is one of the main uses of horizontal presses. In this case, we'll produce a squared figure with an inner wing of 75 millimeters. Pieces like this one and others will be shown next. They cannot be produced with conventional bending machines as the sheet metal always collides with the back gauge on the machine. This means the geometry cannot be completely closed. To produce pieces with smaller closed bends, you use this punch with a 22 millimeter diameter. You add a protective mechanism to prevent the shell from entering the machine. When the tooling is fragile due to the dimensions, the machine pressure should be regulated to adapt it to the type of work to be done. Press the bending icon. Choose the punch you're going to work with, P22. The corresponding V mold, 16 millimeters. The material you're going to work with, 45 kilo iron. Sheet thickness, 1.5 millimeters. The angle at which you wish to bend, 90 degrees. You indicate the position of the punch, front or back. Indicate the distance you'd like between the punch and the mold, 5 millimeters. Press on the second bend and set an angle of 90 degrees. You do the same process for the third 90-degree bend. You save the program by pressing above the asterisk and enter a name that you'll easily identify another time. Put the machine in automatic, press the Start button and start production mode. Do a first bend and check the angle, 93.2 degrees. In editing mode, correct the 3.2 degrees required in each one of the bends. Repeat the first bend and continue until the piece is properly finished. For safety reasons, you must always stop the machine before switching tools or handling another mold. Place the mold in the correct position, secure it in place, and make a few bends with 10 millimeter thick sheet metal. There's a slight mark in the final piece, which was made during the bending. To minimize it, just replace the mold used with the one with a larger opening, so the mark on the piece will not be noticeable to the touch. If you want to create bends up to 161 millimeters high Using the Promecam punch holder is recommended. Secure it to the table, adjust the parallelism, and you can easily couple any Promecam puncher. There are several punches in different molds that can be exchanged indistinctively depending on the work to be performed. You can bend a round rod. It's solid with a squared and rectangular section. Thick sheet metal with a maximum thickness of up to 20 millimeters. Make bends with large radiuses of up to 100 millimeters in diameter in different sheet thicknesses. Double the construction area to do formwork. The bending system on horizontal bending machines makes it easy to bend an angled frame, completely closing it. There are mold systems like the Rolla-V that prevent any type of mark on the bend. Therefore, they are particularly suitable for pieces without any type of finish, paint, or subsequent treatment. An inverted Promecam punch holder is sometimes necessary due to the geometry of the piece. Place the punch holder in the proper position. Tighten the screws so the punch stays in place. Put on the mold holder guide. Insert the hardener support and position the corresponding mold. It's important to decrease the machine pressure to avoid damaging any piece. Press the pedal until the punch and mold collide. This ensures correct parallelism and alignment. Adjust the screw and tighten the lock nut. These pieces are protective mechanisms for fixed ladders for construction at heights. As can be seen, making the bend once the piece is curved is impossible. This is a clear example of why inverted punch holders are used. Let's do an example. Let's bend a plate, in this case made of iron. You position it in the machine and make a bend on each end. The Nargesa engineers have designed a novel CNC gauge equipped with the latest technology and the most advanced features, which will be gradually shown throughout the video. Its speed, up to 1,000 millimeters per second, along with its absolute precision and repetition of more or less 0.02 millimeters, make it the best ally when manufacturing highly complex pieces as part of small and large productions. In this case, we're making a 5-point star. The gauge precision is highly important to getting good results. Two interchangeable point blades come with the machine. One with 2 contact areas, which is also oscillating. Another fixed one with more contact surface area, which we'll use later on. To make pieces where the gauge must be over the mold, the point blade must be oscillating to avoid possible damage. Retracting the gauge. We're going to make a piece for which the work cannot be done correctly without retraction. As can be seen, the piece bends. Let's repeat the piece, but now programming the gauge retraction to 50 millimeters on both bends. Save the changes. Let's make a new piece. When the punch begins bending the sheet metal, the gauge moves back those 50 millimeters to avoid collision. Let's make this orthogonal piece. Press the bending icon. Choose punching. The corresponding mold. Choose the material. Enter a thickness of 4 millimeters. Choose a 10 millimeter opening between the punch and the mold and enter the 135 degrees for the first bend. The point blade on the gauge has two contact areas, one in the front and one in the back. Choose the back area for more gauge length as per the specifications, 1,256.3 millimeters, and enter it in the first step. Add step 2 to the program and enter 135 degrees for the second bend. Place the gauge at 1,108.8 millimeters. You can see how all the other parameters stay the same. Add step 3 and enter 135 degrees for the third bend. Place the gauge at 961.3 millimeters. Continue adding all the steps to the program as per the drawing specifications until you reach the final bend. Press the asterisk at the top left to save the program. Assign a name and save. Choose Step 1. Activate the motor automatic operation and production mode. Press the pedal so the gauge moves to the first elevation. Position the sheet metal in the back of the point blade. Press the pedal again so the piston moves forward and repeat the cycle until the piece is finished. Replace the oscillating point blade with the fixed one with a greater contact surface. Punch P.U.67.14 has a large variety of radiuses up to 50 millimeters, which can be easily interchanged to make bends with large radiuses. We're going to make an embellisher with 2 millimeter sheet metal featuring a radius of 30. This type of tooling is often used to manufacture designer furniture. In this case, we're making a leg for a garden bench without any welding in a single piece. No straight edges. Very simple, avant-garde, and modern at the same time. You switch the 30 radius element for the 12.5 millimeter one. Place it in the punch holder and secure it. We're going to produce a support with a 16 by 16 square rod. One of the many sectors of application for the PP200 is also the electrical sector, where copper bus bar manufacturing for distribution boxes is particularly effective with this press. When used in combination with the automated gauge, it can create flat and edged profiles quickly, accurately, and with the best finishes. The immense versatility as far as tooling makes it possible to create rods of different thicknesses, profiles, and sizes, which adapt to the most complex circuits and the highest degree of quality. You can couple special simultaneous bending and flattening tools to achieve two objectives. On the one hand, enhance the safety of the pieces made by making anti-cut edges, and on the other hand, continue having a bend mold available to create complex pieces. Now, let's do some calendering on 150mm wide sheet metal that's 4mm thick, following the drawing specifications. Choose the menu, Programs. Choose the technology to be used, Bending. New program. Choose the punch and mold you wish. Material, 450 iron. Thickness, 4mm. Opening between the punch and mold, 5mm. Add the first angle, which is 175.9 degrees, and the first gauge distance of 295.3mm as indicated by the drawing, and choose the back area of the point blade. Add step number 2 and enter the 171.8 degrees for the bend. Place the gauge at 280.7mm. Step number 3. Enter the 171.8 degree bend and place the gauge at 266.2mm. Following the same process, go about adding all the necessary steps to the program until the 12 bends indicated on the drawing have been completed for the calendering. To finish, program the last two bends at 90 degrees, choosing the front of the point blade and choosing a gauge distance of 67.7mm. Save the program. Choose step number 1. Automatic mode. Start the press and begin production. It's important to mention that the number of bends and the separation between them when calendering influences the level of surface finish. In other words, the more bends and the closer they are together, the better the finish. Let's move on to the punching option. To do so, position the tooling, tighten the screws in the head, and secure the mold to the table. The extractor has different openings depending on the size of the punch used. Insert the 40mm mold into the base. Screw the punch into the thread. Choose punching. Choose the punch geometry, circular. The diameter, 40 millimeters. Choose the material, 450 iron. The thickness of the material is 3 millimeters. This field indicates the tonnage of the press required to do the punching, in this case, 17 tons. If you increase the thickness of the material to 8 millimeters, the software indicates that the hydraulic power necessary is 45.2 tons and highlights this in red, as the machine would not be able to do this operation. With these parameters, the software has the piston front end of run, so the punch is inserted 2 millimeters inside the mold. Lower the extractor and adjust it so the sheet metal passes through. Adjust the opening between the punch and mold to 12 millimeters. Start the machine. Automatic mode. Production. Place the side gauge as per the dimensions and the machine is ready to punch the piece. If you want to increase the durability of the punches and molds, they must be lubricated periodically. We'll run a program with just one step to punch this 10 millimeter sheet metal. Choose the technology, punching. "16 millimeter round punch." Choose the material and indicate the thickness. Program the piston to move back to 17 millimeters. Save the program. Automatic on. Production. The punching tool has two side supports to help regulate the height where you wish to make the hole. The punch and squared mold can be adjusted to create a diamond shape. Now we'll run a program using overlapping punches. Go to the menu, Programs, Punching, New Program. Choose the 17 by 40 millimeter oval punch. Material, 450 iron. Thickness, 2 millimeters. The first gauge at 200 millimeters and set an 8 millimeter reverse. Add step number 2 with a gauge elevation of 300 millimeters. Create step number 3 with a gauge distance of 400 millimeters. Step number 4 with a gauge distance of 600 millimeters. Step 5 with a gauge distance of 700 millimeters. Finally, step number 6 with the gauge at 800 millimeters. Save the program. Choose step number 1, automatic mode, on and production. Finally, rotate the mold and punch and run the program, repeating the process on the same sheet metal. Manually adjust the gauge Z-axis. Let's do a series of square punches separated 120 millimeters from each other. Menu, Programs. Punching. New program. Choose the 14 millimeter square punch. Material, 450 iron. Thickness, 6 millimeters. The first gauge at 120 millimeters, and program an opening of 12 millimeters. Add step number 2 with a gauge elevation of 240 millimeters. Increase the gauge elevation by 120 millimeters for each new step added until you get to the last one, number 10. Save the program. Choose Step 1, On, Automatic Production. You rotate the hand railing and insert it on the other side to repeat the program and finish this piece. Nargesa has an extensive catalog of punches and molds in different shapes and sizes. You can flare 16 to 50 millimeter pipes to be welded at 90 degrees. You can flare with or without an evacuation hole for galvanizing. Produce lugs of different types, in different shapes and sizes, with a rounded edge, 2 rounded edges, with or without holes. Each piece is manufactured in just one stroke. Depending on the length of the gauge, you can get longer or shorter pieces with the same mold. With a mold to curve profiles with large radiuses, you can do all types of bends on different profiles. Press the multi-purpose icon, press the pedal, and observe how the BA elevation, which indicates the current piston position, decreases as the piston moves forward. Stop when you see the material easily enter the mold and enter the BA elevation in field A. This elevation represents the back end of run point. Get the piston to move forward again to check that the material fits in the space between the die and counter die. Enter the elevation in field B. This will be the front end of run point. Press Automatic Mode and Production. In Field B, increase the elevation from 60 to 75. This way the curve will have a larger diameter. The capacity and robustness of the machine means it can bend a plate up to 140 by 20 millimeters. Secure the support for the head clamp. Grease the area of contact. Insert the clamp holder cone in the support and screw it in. You put on the reduction clamp. Put the 3 pins in and screw the main support to the table. It's important to lubricate the tools subject to a lot of friction to increase their durability, enhance the finish, and make extraction easier. Slide the clamp inside the cone until the pipe to be reduced fits without too much of a gap. Enter 158 as the elevation BA in Field A. The outside diameter of the pipe is 50 and the thickness is 1.5 millimeters. Move the clamp forward until you get a measurement of 46.5 millimeters. Enter elevation BA in Field B, corresponding to the final position, 134.5. Reduce and check that the dimensions are correct. The reduced end should fit easily inside another pipe. Save this program for future work, indicating the reduction range, 50 to 46.5 millimeter pipe. There is a wide variety of clamps for pipes, from 16 to 73 millimeters with a maximum reduction length of 76 millimeters. If you'd like a lower reduction, cut an already reduced pipe and insert it inside the clamp, as if a gauge. This way, you'll get the dimensions you want. To widen a pipe, put in the clamp holder and expansion mandrel. Move and secure the main support. We have a catalog of clamps for pipes from 22 to 60 millimeters with a maximum reduction length of 80 millimeters. This tool can produce circular shapes with an outside diameter of 90 millimeters. To join or decorate iron bars and bend the railings with different angles. The profile hardener mold is used to harden and bend. Depending on the profile capacity, you join or separate the support points for best results. These examples demonstrate the versatility of this tool. Position the cutting mold and screw it into the machine head. Choose the cutting icon. Type the material to be cut, aluminum. Thickness, 10 millimeters. Opening between the knife and sheet, 5 millimeters. Automatic mode, on, production. Depending on the thickness of the material to be cut, adjust the support point with a minimum gap to get a good cut. Put the manual gauge in position. You can cut all types of materials with different formats: a plate or flat iron, round solid, square solid, and fine sheet metal. Let's do a short program with the automated gauge. Menu, Programs, Shearing icon. New program. Material, aluminum. Thickness, 3 millimeters. You define a first gauge at 100 millimeters. Step 2. Program the next gauge at 200 millimeters. Assign a value of 300 millimeters to the gauge for the third step, and finally, program a 350 millimeter gauge for the fourth and final step. Save the program. Choose Step 1, Automatic, On, Production. Place the Z-axis in position and successively do each cut pre-programmed beforehand. Insert the plugs for protection against the shelling during the bending process. Put the tool in position, insert the bolts, and screw in the tool. Grease all points of friction. Put the counter die in place and screw it in as well. The machine's now ready to produce. Lower the operating pressure and adjust the manual gauge. Choose the multi-purpose option. In manual mode, move the piston forward to an elevation where the material can easily enter. Press the Edit icon to enter this BA elevation in Field A, 226. Remove the material and get the piston to move forward again. Stop the movement as soon as the space between the die and counter die is equal to the thickness of the profile. Enter the current value of elevation BA in Field B, 173.5. Production, automatic. The PP200 horizontal press comes with an extensive catalog of shapes to make different types of decorative bars. As can be seen, the possibilities are endless, and the results are perfect. Adjust this tool based on the thickness of the material. Secure the lateral gauge, and you can produce staples to join rods with different shapes. Depending on the dimension of the piece mounted as the tooling, you can bend steel of different thicknesses. Joined together, the resulting pieces make it possible to form braids to manufacture bars and railings. Another of the many uses of a horizontal press is to form clamps of different sizes and shapes to join pipes together. These elements are often used to build greenhouses, construction structures, scaffolding, hold cables and conduits, assemble antennas and communication systems, ventilation and air conditioning systems, mount irrigation systems, and much more. The multi-purpose mode is available when you wish to use special molds with the machine. Here, you just define the values of the two elevations, A and B, respectively. The most outstanding features of the all-new CNC PP200 horizontal press. To prevent small bits of metal from entering the table during operation, the machine comes with a few plugs and some studs for Allen wrenches, which can be easily interchanged depending on the mold used. Anti-wear Hardox 400 sheet metal in areas of contact. A manual adjustable gauge that can be regulated in different positions. It can be placed on the left or right side of the machine depending on the piece to be manufactured. Precision and repetitiveness of more or less 0.02 millimeters. Standard equipped with 3 fixing bolts to couple all types of molds. Safety pedal down in a sustained manner. If you press the pedal down suddenly, the machine will automatically stop. Echo mode stops the hydraulic pump on the machine automatically during periods of inactivity to save energy. Tooling shelf. Possibility of moving the machine easily with a forklift to operate or to store it if there's a lack of space. Hydraulic pressure regulator. Adjusting the mold holder. To adjust it well, screw in the mold to work with the smallest V, lifting it up a millimeter from the table to prevent friction against it. Put the standard punch-on in the right place. Graduate the pressure regulator to a minimum. Activate the multi-purpose mode. In manual mode, press the pedal to get the mold closer to the punch until both fit without excessive pressure. Once adjusted, tighten the screws on the mold holder. Activate automatic mode so the machine will reverse. Stop it for safety reasons and then switch the mold and punch, knowing that it will always be centered. How the machine works. Switch the power on. Exit the alarm warning. This is the main screen where you choose which operation to do. Punching. To delete the alarm notification, press Reset. Choose the punch. Shape and dimensions. Choose the material. Thickness. This field indicates the power the machine requires to do this operation. Gauge elevation. Gauge retraction. Manual or digital adjustment of the opening between the punch and mold. Area of contact between the material and the gauge, back or front. In automatic mode, the piston moves back as soon as you stop pressing down on the pedal. In manual mode, the piston stops upon releasing the pedal. Add a new step to the program. The material and punch specifications remain the same. You just have to edit the gauge elevation. Save the program. Delete the last step from the program. Save changes. Activate automatic mode and the hydraulic pump. Production. You can return to editing mode at any time and make changes to the program. Save. Main screen. Bending. List of punches. List of molds. Material. Thickness. Bend angle. Bend angle correction. Gauge elevation. Opening between the punch and mold. Punch position, front or back. Area of contact between the material and the gauge. Automatic mode and manual mode. Add steps to the program. Delete the last step. Save program. Automatic. Start the pump. Production. Return to the main screen. Cut. Choose the material. The thickness. Gauge elevation and retraction. Opening to insert the material. Area of contact with the gauge. Automatic or manual mode. Add steps to the program. Delete the last step. Save. Automatic. Start the pump. Production. Add steps. Save changes. Main screen. Multi-purpose mode. You can choose the initial elevation and end of run for the piston manually or digitally. A indicates the start position and B the end piston elevation. Gauge elevation. Add steps to the program. Area of contact with the gauge. Automatic or manual mode. Save. Start the pump. Automatic. Production. Functions available on the main menu. Programs. Choose the operation, in this case, bending. List of saved programs. From here, you can edit, duplicate, delete, or rename programs. Create folders or create a new program. Alarm diagnosis. Import and export data from a USB to the machine or vice versa. Choose all the filters you want to export to have a complete backup copy of the parameters. Another main advantage to the Nargesa PP200 horizontal press brake is the built-in 4.0 technology. Whenever a customer agrees, our technical service can remotely connect to update the software, find anomalies, and even use the machine without needing to travel. The benefits of 4.0 technology are endless, and the distance between the customer and manufacturer disappears. The Clean Screen tool is a feature that disables the screen for a few seconds to be able to clean it without activating any applications or commands. A mechanized table on the side to add a manual 300mm CNC gauge for the Z-axis if requested by the customer. The maximum X-axis run is 1,210mm. Precision and repetitiveness of more or less 0.02mm. Automatic management of 2 speeds. a high speed of 1000 millimeters per second while outside the security area, and another slower speed for movements near the mold and punch. Two interchangeable point blades come with the gauge. One is oscillating with 2 points of contact, the other is fixed with a greater support area. Contact area is built in anti-wear Hardox 400 material. Total control over gauge movement using the safety pedal. Automatic programmable retraction as needed for the piece. Servo motor drive system, unlike other gauges which are powered by a convention motor and an encoder. Now I'll explain how to assemble the gauge correctly. Open the box and take everything out. The instruction manual, the screws, the eye bolts and rectified pins, which will be used for assembly. Using a plastic mallet, insert the 2 pins into the holes on the sides of the press table. Remove the leg from the box. You can work with the gauge by screwing in the eye bolts and moving it with a bridge crane, or by having 2 people move it together. Place it on a table or workbench. Remove the 8 screws and slightly move the upper cover to get access to the machine assembly interface. Remove the screws from the leg cover. Couple the gauge to the machine using the 2 rectified pins and screw it tightly to the table. Put the upper cover on and screw it into the structure. Screw the leg to the main gauge body. Adjust the 2 levelers until there is contact with the ground. Check that the gauge is level. Position the leg cover and tighten the screws. Finally, make the electrical connection between the gauge and the machine by assembling the multipolar male connector on the gauge to the female connector on the machine. Then, you activate the gauge. Go to Menu, Gauge Configuration. Activate the 2 parameters shown on screen and then select Manual Mode. Stop the machine by flipping the switch off. Wait a minute and reactivate. The gauge is then connected to the PP200 and ready for final adjustments. Now, let's set the 0 point. In other words, the exact dimension between the center of the mold and the gauge point blade. Adjust the Z-axis manually so it doesn't collide with the mold, yet there are still a few millimeters. Lower the pressure and activate multi-purpose operation. Reset and activate the hydraulic pump. Enter elevation 240 in field A, elevation 0 in field B, and position the gauge at 1000 millimeters. See how the gauge moves towards the homing position and then moves to the distance set of 1000 millimeters. Move the piston forward in manual mode until the punch and mold collide. Tighten the screws on the mold support well. Press the right pedal so the piston moves back. Choose Menu, Axis Configuration, X-axis. Press the position icon. Enter a distance of 100 millimeters in the upper field and confirm. The gauge will move to the specified elevation. Now use a caliper to take the exact measurement between the end of the mold and the gauge point blade. This time, just as an example, this value is 132.8 millimeters. You know the mold is 60 millimeters, meaning the center is at 30 millimeters. Subtract these 30 millimeters from the 132.8 millimeters measured in the first step. This gives you 102.8 millimeters from the center of the mold to the end of the point blade. Subtract the 100 millimeters configured previously as the gauge position, and the final result indicates the gauge differs by just 2.8 millimeters from the zero elevation set. Go to the menu, Gauge Configuration. The elevation of 1,186.5 millimeters is shown in the zero position field. Add the 2.8 millimeter difference and enter the new value of 1,189.3 millimeters. The gauge is now perfectly adjusted. Activate manual mode to begin working. Now I'll explain how to choose the right V for each sheet metal thickness. The best thing to do is choose a groove with the width obtained by multiplying the thickness, expressed in millimeters, by 8. For example, use the smallest V, 16 millimeters, for 2 millimeter sheet metal. The V would be 24 millimeters for 3 millimeter sheet metal. If you don't have the exact V, use the one that's closest to it, no matter if it's bigger or smaller. Use a 32V for 4 millimeter sheet metal. Using a 48V is best for 6 millimeter sheet metal. There's no problem if you use the 50 in this case. You can use a 63V for 8 millimeter sheet metal, as it's just 1 millimeter below the ideal situation. Use the 80V for 10 millimeter sheet metal. Use the 100V for 12 millimeter sheet metal. If you want larger bend radiuses, you must use a larger V. On the contrary, if you want smaller bend radiuses, you must use the optimal V or a smaller one. To bend sheet metal up to a maximum of 90 degrees, you can use 85-degree Vs. If you want to bend angles less than 90 degrees, like this 60-degree one, you should use Vs that are more closed, like these. To manufacture fully closed shapes with small wings, use the smallest V, which is 16. And you use this 22 punch to close the geometry of the piece. This is one of the greatest benefits of horizontal press brakes. For other geometries that are also closed, like this one, you must use a lower degree punch. For example, this 30-degree punch, along with this mold, to bend it up to a maximum of 35 degrees. This combination allows the punch to enter the mold without colliding for best results. If you use a punch over 35 degrees, it will collide with the ends of the mold. This is the Promecam punch holder, where you can couple all of these punches, each with their own uses. Use this type of punch to bend pieces that are rather complex. The shape means you can leave small wings, which is impossible with other type of punches, as they will collide with the sheet metal. The next punch is used to bend closed 90-degree angles. This is the most standard one and the strongest. It can do almost anything. Use this last one for thick sheet metal. For bends with larger radiuses, use a radius holder with different couplings. In this case, up to a maximum of 7.5 millimeters. The next radius holder can bend radiuses up to 50 millimeters, and it's also interchangeable. All of the punches shaped like this are used to create closed pieces. The others are used to create open pieces. It's very important to know the punch degrees. For example, this is the most common one. It has 85 degrees, and you can combine it with V's equal to 85 degrees or higher. This 30-degree punch can also be used with larger Vs, such as an 85-degree one, as it will never collide with the corners of the V. On the other hand, never use 35-degree Vs like this one with 85-degree punches. You must combine them with punches that are 35 degrees or less. Thank you for continuing to trust Nargesa.